So graphene, which was the world's first two-dimensional material, has unique and different properties to that exists as a three-dimensional material. So for example, graphene is 200 times stronger than steel. It's the most conductive material. It's flexible, it's transparent, and can act as a perfect membrane to block different molecules. So really graphene as an example of a two-dimensional material has these unique and different properties to that exists as a three-dimensional material. So it really does open up a whole range of possibilities for new products and applications, from energy to aerospace to automotive to medical. So graphene and 2D materials has many different products and applications. Near term, we're working on, for example, adding graphene into rubber to end up with a rubber that is both grippy but is also durable. So for example, in car tires or in training shoes, where you want both grip, but durability gives you longer life and better environmental performance. Other areas where we're working are, for example, graphene concrete. So by adding a very small amount of graphene into concrete, you can potentially lay floors or buildings without any metal reinforcement using less concrete. So less material costs, but also less carbon dioxide. So the list goes on is really endless. So everything where you want a mechanical improvement, a lighter aircraft, a lighter car, or a longer lasting battery. So graphene and 2D materials really have the opportunity to transform almost every sector that we work in. And in particular, when we look at sustainability being a key drive as we go forward, it can also offer opportunities for greener products and applications. So we have three main facilities around advanced materials in Manchester. We have the National Graphene Institute, the NGI, the Sir Henry Royce Advanced Materials Institute, and we have the Graphene Engineering Innovation Centre, the GEIC. Royce and the NGI are very much around bringing together the multidisciplinary science around advanced materials. So bringing together the scientists from materials, with physics, with chemistry, with engineering, and to accelerate that early stage from discovery through to a laboratory-based prototype. We also have the unique capability of the GEIC, which is more about the translation of that science into products and applications. How do we move from a lab into a factory through the so-called valley of death in terms of scale up, pilot production of both the materials, but also the various applications involved in 2D materials. So that's all part of the University of Manchester, but we also have a unique business model, which is in partnership with industry. So we work closely with industry, whether it's around making materials or using those materials in applications, through to end users who might pull through those particular products into the marketplace. So all in all, the three facilities create that critical mass, but working with industry is very much around the business model we're trying to accelerate materials into the marketplace. So the discovery of graphene is a great story around curiosity-driven research. Two scientists from physics, driven by curiosity, took some sticky tape and some graphite, and you can all try this at home. If you take the graphite onto some sticky tape and then peel that sticky tape over many, many times, you can isolate a single atomic layer of carbon. So what is graphene? It's got length, it's got breadth, but one atomic layer thin or thick, it's the thinnest possible material. So what, when they measured this 2D material, it had these unique and differential properties, like stronger than steel or conductive than copper. And it's now actually a family of over 100 other 2D materials. And today, one of the ways they still use is sticky tape and peeling the material many times to get this single atomic layer. Industry has taken over with graphene, and now there are many ways of making graphene, not by the gram, but by the kilogram, by the ton. But for science, they're still using sticky tape as an example to isolate single 2D materials. Graphene has these fantastic uses. One of the most exciting, slightly longer term, probably in terms of commercialization, is that around medical. So I'm aware of work around the paper you talked about, also around everything from drug delivery through to artificial limbs, through to there's some very interesting work around graphene in the brain. So I think you're going to hear more about graphene in some of these really interesting medical type areas. Clearly, near term, there's quite a lot of work around biosensors. Can we create a sensor that can detect these new forms of viruses like COVID? So again, graphene and advanced materials can play a key role both in general applications, but also in terms of biomedical and medical applications in the future. So the University of Manchester has a broad activity around sustainability, and it recently ranked #1 very highly across the board in terms of activity on sustainability. Specifically around advanced materials, it's a key drive from our customers today who want lighter aircraft, for example, that use less fuel, go further range, less emissions, through to aircraft or cars that want new forms of batteries or supercapacitors or energy storage. So graphene plays a key role both in terms of lightweighting, making things lighter, less fuel, less weight, less emissions. Also in terms of energy storage, new forms of batteries, fuel cells, hydrogen, all examples where advanced materials, graphene will play a key role in the future. Another key drive we're finding though, and very exciting, is that graphene can also improve the recyclability of a material. If I take, for example, scrap rubber tires, normally it's quite expensive and difficult to recycle them, and hence tires end up on scrap heaps, set fire to, causing pollution, causing environmental damage. One of our partners takes a scrap tire, chops it up into small rubber crumb, and then through the addition of graphene, we actually get a rubber that has higher performance than the traditional recycled rubber product. So again, it's a good example of recyclability where we're taking something that's waste to actually recycle that and reuse it. And again, there are many other examples from concrete I talked earlier, through to plastics, through to taking scrap material and reusing it around a circular economy. So graphene and 2D materials increasingly will support the sustainability agenda we have in the future. So the Advanced Materials Show in July is going to be quite a first for many people, in that it's probably the first event that many people will have been to since the COVID lockdown. So I think myself and many others are actually keen, again, in a safe way, to engage with other partners, people, future partners going forward. So the Advanced Materials Show has been great in the past of bringing people together, from material suppliers to end users to product manufacturers. So again, I think it'll be good to network with those various people in a safe way. We're having a very limited presence, but we have a good presence there where we can talk to people. We can link back to our main site where we have experts on standby if there are any detailed technical questions. So I think in summary, we're really looking forward to getting out, to engaging in a safe manner, but also to start to talk about some of the significant developments that have taken place over the last 18 months. Indeed, I've actually seen an acceleration of the adoption of graphene and 2D materials into products and applications. And it'd be great to be able to share some of those developments with the audience at the show. So advanced materials are a cross-cutting technology that go in almost everything that we do. We often talk a lot about digital, and yet digital is very important. It's a key sector, it's a key value. But everything we manufacture, everything we do in terms of driving, flying, building, construction, advanced materials or materials play a key role in what we do. I think in the future, you're going to see these new forms of materials, whether it's graphene added into concrete, graphene added into carbon fiber, or 2D materials into electronics. Advanced materials increasingly will play a role in our future, and particularly driven by sustainability. Some of the challenges that we have, net zero by 2050, I believe we need to adopt and accelerate some of these advanced materials to achieve some of those quite challenging targets. Net zero is a good example. 2038 up in Manchester for net zero is a target. So that means we need to start doing our construction and new buildings differently now. We can't afford to wait. So examples like graphene in concrete, where we can reduce the amount of concrete, we can reduce the amount of CO2, reduce metal reinforcement. Again, it's a key step towards achieving those challenging milestones. Advanced materials will play a key role in that, and the activity we do in Manchester will remain a critical mass of activity in support of that. So one thing we want to do is to share some of our stories, some of our activity, but we're also looking for industry who have got key challenges going forward in terms of meeting sustainability targets. It could be packaging, it could be construction, it could be automotive energy usage. So our business model is both, we do research, we do teaching, we do training in the National Graphene Institute in Royce around the fundamental research. But the Geek is more challenge-led. So we want industries with real challenges, real problems to engage, to see how through the application of advanced materials, we can help support industry in solving those problems or challenges. And one of the great things about graphene, it's not just the large corporations. We also work with small and medium enterprises. We work with spin-outs and spin-ins here at the University of Manchester. Give you a couple of examples. We have an SME who's making a new form of hydrogel for growing plants in the future. It doesn't use peat, it doesn't use rock wool, which are environmentally unfriendly, but it will also potentially enable vertical farming. So again, in support of sustainability, food production, small company based here in the Geek in Manchester, who we're working with to really accelerate that to market. So yeah, looking for companies who have challenges, have problems, and companies who we can support accelerate their products into the marketplace.